consider the basic properties of different magnets, like the directive property, already we have observed. Directive property is that whenever a magnet is suspended freely, it always comes to rest or takes the direction of north and south poles of Earth. Reason also can be understood directly, because Earth is a big magnet. It comes to the direction of the Earth's magnetic field, that is geomagnetic field, what we call it. That is one. When we consider the poles of a bar magnet or of any other magnet, magnetic poles cannot be isolated from one another. A magnet, when it is existing, it should have both the poles. Separate north pole or separate south pole, or in other words, isolated north pole or isolated south pole can never exist in the universe. So whenever we talk of any magnet of any shape and size, surely that magnet is going to have both the poles. And one thing more we know, like poles used to repel each other and unlike poles used to attract each other. Like poles in the sense, say two north poles of two different magnets, when they are made to come closer or placed one adjacent to the other, they repel each other. Whereas once north and other one's south, when they come closer, there will be attraction between them. What would be the force of repulsion and what would be the force of attraction? How to calculate them? For that, we have the equation Coulomb's law. That's what we call it as inverse square law. Coulomb's inverse square law. That is the one. When we consider there are two north poles of two different magnets, say, which are separated by a distance r like this, when their pole strengths are m1 and m2 respectively, then the force of repulsion, when one is north and one is south, that is called force of attraction that time. Whether it is force of repulsion between the magnets existing or force of attraction that is existing between the poles, magnitude will be the same. Only thing is the direction that varies. So whenever we consider this Coulomb's inverse square law, the force of attraction or repulsion between two magnetic poles having pole strengths m1 and m2, which are separated by a distance r between them, is directly proportional to the product of their pole strengths and inversely proportional to square of the distance between them. In fact, this part of this law itself is called inverse square law as such. So when you consider this, a constant of proportionality mu naught by 4 pi into m1 m2 by r square, that is the basic equation what we used to write. Out of that one, this is taken in air, for example. That means the material medium that is existing between these two poles is air. Now we can understand this mu naught here as permeability of free space. This free space, of course, we used to consider either air or vacuum. And what is this value as far as free space that is concerned? 4 pi into 10 power minus 7 Henry per meter. Once again, what is 1 Henry means? It is nothing other than volt second per ampere. In other words, we can say ohm second. So you can write Henry per meter. This is the value of mu naught. This now implies mu naught by 4 pi, which is a constant of proportionality over here. That simply becomes 10 to the power minus 7 for free space. Therefore, whenever we just calculate the force of attraction or repulsion between two magnetic poles which are separated in free space, directly we can use this formula, and we can even take mu naught by 4 pi as 10 power minus 7. What is that corresponding unit again? Again it can be taken as Henry per meter. That is the concept. Now the next concept is, there is no rule that every time the magnetic poles are supposed to be separated in free space only. There may be a material medium which we can provide between them. In case of any other medium other than air or other than vacuum, when we are having in between the poles, then this force of attraction or repulsion, since it even depends on the material medium between those two magnetic poles existing, definitely that force varies. How to just estimate or calculate that amount of force between the poles that time? So when we consider this way, in any other medium, when the poles are being separated, how to just write this equation, that force of attraction or repulsion between the magnetic poles separated in the corresponding medium? That now can be written as mu by 4 pi into m1 m2 by r square. The difference every one of you can easily understand here. Mu naught refers to free space, whereas mu refers to the other medium which of course is separating these two magnetic poles as such. So when I consider here where this mu is called absolute permeability of the medium, first and foremost you can even understand the phrase that is permeability, whether it is in the case of free space or of any other material medium. It is, in one sense we can say like this, permitting ability. The ability to permit what? The ability of the material medium to permit the lines of force to interact one with the other. The magnetic lines of force, which of course are of the first magnet, of the second magnet, they should have some sort of an interaction, either when they want to attract each other or they repel each other. Whatever be the case, the material medium should allow the magnetic lines to pass through it. When the material medium is not allowing the lines of magnetic field to penetrate through, there will never be any sort of a force that can be exists in between those two. In a sense, what one can understand, unless the medium is assisting the magnetic poles, they will never attract each other or repel each other. That is the condition one need to understand. So how to write this value here? Mu can be written as mu naught into mu r. Of course, we can understand mu r is relative permeability, of the medium, whichever medium we are considering over there. Just writing that formula over here, we can directly conclude this way: force between the poles when separated in a medium other than free space, we can rewrite that same formula this way: mu naught mu r by 4 pi into m1 m2 by r square. This is the formula for the force between the magnetic poles when are separated in a medium other than free space. So when once we consider this equation here, in what manner or how we can define this mu r in terms of forces? This equation and this equation, when I consider, mu r can be written as F medium divided by F air. You can even write the same equation from this one as well. It is mu by mu naught. Now just look at these two equations carefully. Relative permeability of a material medium can be defined in two different ways. What is the first one? Relative permeability is the ratio of absolute permeability of the medium to the permeability of free space. Mu is absolute permeability of the medium, mu naught is a permeability of free space. That ratio we call it as relative permeability of that medium. That's one method of defining. What is the other way of defining? It is the ratio of force existing between two magnetic poles which are separated by certain distance in the medium to the force existing between the same poles separated by the same distance in air. So what we should understand, F in medium by F in air, what should be constant in both the cases? Whether they are separated in air or in medium, distance of separation should be constant and same magnetic poles are to be considered over there to calculate this ratio, which can give us the relative permeability of that material medium as such. So when we take F medium and F air, directly when you divide one by the other, you can get the value of relative permeability of the medium. So what one should understand from this one, F medium value truly speaking will be greater than F air, that is the case. So this is actually the concept of Coulomb's inverse square law, which can give us the idea about the force of interaction between two magnetic poles when they are separated by certain distance like.